Decimal representation. There are different types of decimal numbers. Terminating, which have a finite number of decimal places, such as 0.5 or 0.25, 0.1, you could think that these have an infinite number of decimal places where all the rest are zeros, but you wouldn't bother writing them down. Then we have recurring, which repeat in a pattern forever. So 0.3 recurring. A recurring can be shown either by a bar or a dot, and that's 0.3333, and so on. Or 0.25 recurring, note the bar is only over the part that recurs. Or 0.23684, which repeats like this, note that this bar goes over the top of the whole section that repeats. Or you could show that with just a dot on the 3 and a dot on the 4. We can also have decimals which don't recur, so they have an infinite expansion and no recurrence. But both of these can be written in fraction form m over n, whereas the non-recurring ones can't, where m and n are integers and n cannot be 0. For example, a half is 0.5, a quarter is 0.25, a tenth is 0.1. All terminating decimals like these, when expressed as a fraction, have denominators which have factors that are powers of 2 and 5 only. So here we had 2, 2 squared, and 2 times 5. 1/3 is 0.3 recurring, 1/6 is 0.16 recurring, so just the 6 recurs, and 1/7 is 0.142857, 142857, 142857, and so on forever. Convert the following decimals to fractions. So in part A we have 0.125, tenths column, hundredths column, thousandths column. So we can look at that as being 125 thousandths, and that cancels down to 1/8. In part B we have 99.9, and that's 99, and then we have 9 in the tenths column. Now in part C we have a recurring decimal. Now there's many ways of doing these, but I'm just going to go through one of them. So what I'm going to do is I'm going to let x be equal to 0.25252525 and so on. So I'm letting x be this number. Now my recurrence pattern is 2 digits long. So what I'm going to do is multiply that by 100. If this had been 1 long, like this one, then I'd have multiplied by 10. That gives me 25.252525 and so on. So what you'll notice is the decimal part of both of these numbers is the same. So if I do this take away this, I get 99x is equal to 25, because the decimals will disappear. So x is going to be 25/99. Now let's do that for part D, although I can tell you straight away that 0.9 recurring is going to be 1. So let x be equal to 0.9999 and so on. Then 10x will be 9.9999 and so on. So if we now subtract, that's 9x is equal to 9, so x is 9 over 9, which is 1. It's worth remembering that 0.9 recurring and 1 are actually the same. We want to convert the following fractions to decimals, and for these ones I'm just going to divide. So I'm going to put 23 and give myself some extra decimal places here. So 9's don't go into 2, 9's go into 23 twice, and leave a remainder of 5. 9's go into 50 5 times, leaving a remainder of 5. 9's go into 50 5 times, leaving a remainder of 5. And we can see that this is just going to carry on forever, so this must just be 2.5 recurring. Now let's do 6 into 23. And again, give myself some extra decimal places here. So, 6's don't go into 2, 6's go into 23 3 times and leave a remainder of 5. 6's go into 58 times with a remainder of 2. 6's go into 23 times with a remainder of 2. 6's go into 23 times with a remainder of 2, and I can see this is just going to recur. So that's going to be 3.83 recurring. And we can now do exercise 7.03 on page 256.